Okay, so we're looking at the polynomials. Our goal, again, like I said, we want to identify, evaluate, add, subtract polynomials, classify, and graph. This technically is stuff you have seen before. You've seen it in Algebra 1. We didn't really talk about it in MMA. But it helps lead you into new things. A lot of what you saw last semester, you saw before in Algebra 1 or in MMA. Starting with this chapter, you're going to start seeing lots of new things, which means a lot more extra work and probably a lot more start trying to pay attention closely. If you thought any 6 weeks, including last 6 weeks, was supposedly hard, and that was still easy, you're going to get a lot harder because now a lot of this semester is going to be new material that you've never seen before. But at least the first section starts off easy. Oops. There we go. So let's look. We need to get some terminology first in. A monomial is a number or a product of a number with some variables that have whole number exponents. So you can't have like an x to the negative 2, and you can't have like an x to the 1/2 power. It's really just about it. I mean, you could have 3x squared, you could have the 3, you could have 5x cubed y to the 5th power, and those would be considered monomials. When you take a monomial by itself, it can also be considered a polynomial, or if you combine multiple monomials with addition or subtraction, you get a polynomial. You need to keep in mind, though, a monomial is still considered a polynomial. So every monomial is a polynomial. Not every polynomial is a monomial. So it's like a smaller subset within a bigger group. So you can see some examples here. 3, 5x to the 4th, 2x squared minus 7, and 1/2 8 to the 7th. All those are polynomials. The first, second, and 4th one are still polynomials, but they're also more specific. They're monomials. To be a little bit more specific. That we can find the degree of a monomial. The way we find the degree of a monomial is by adding or subtracting, well, not subtracting, just always adding the exponents of the variables. Just the variables. Now, there's nothing to add. There's only like one variable. That makes it pretty easy. But your degree is based off the exponents. So x to the 4th is still simply x to the 4th, or degree of 4. If I had 12, a number all by itself, there's no variable, so I would say a degree of 0. So keep that in mind. If there's no variable, you have a degree of 0. If you see just like a plain x, you have a degree of 1. So the only way we can have a degree of 0 is if like we're completely absent of a variable, or if I put the exponent 0 with an x. Like if I wrote 12 here as 12x to the 0. I wasn't going to the next slide. I actually got 2 more examples. Here I see 4a squared b has a degree of 3. So that means I had to say 2 plus 1 was 3. Where did I get the 1?
The b?
From the b. Exactly. Even though the b does not have an exponent, it's a 1. Let me rephrase that. The b doesn't have an exponent that I see. It has an exponent of 1. And final example, x to the 4th, y cubed, z has a degree of what?
8.
8.
What's in between the 2 12s?
A little arrow.
Okay.
Dun, dun,
What was?
The degree of a polynomial is if you put them in order. And again, when you look at a polynomial, if you put it in order from highest exponent to lowest exponent, once you put them in order, the term with the greatest degree, with the greatest exponent, is the degree of the whole polynomial. And you'll understand that more about when we're looking at the graphing, how that would make changes to the graphing. So here's one that's written in order, in what's called standard form. 5x cubed plus 8x squared plus 3x plus 7. Looking at that, what's the, and let's do this individually. What's the degree of the very first term? What's the degree of the first monomial? 5x cubed. 3. What's the degree of the second one? 2. Then 1 and 0. Okay. Then obviously the 3 is the, since that's the biggest one, that's the degree of the whole polynomial. And because of that, I can say 5, I call that a leading coefficient. When you have it have them in order, the number that ends up being in the very front ends up being called the leading coefficient. It doesn't matter that there may be bigger numbers, that number is the leading coefficient. We look at the biggest degree or exponent, but the number in front when it's in order for the leading coefficient.
So the coefficient.
Then you need to put it in order. That's what we'll do with the next, like, in another example later.
So the degree for that one is 3?
Yes. So if I ask for the degree of that polynomial, I would say that one is 3. If I ask for the leading coefficient, I would say that's 5.
Why 5?
Because that's the number that's in front. When when it's in order of the one with the highest degree.
Let's say you give to us misordered, do we have to order them?
Yes.
The 5 is called the leading what?
Cool. Okay. So I'm going to give you some examples here. We're going to say, look at the example, what degree does it have, and then the name of that degree. There's specific names that are associated. Like with the square, we know that's quadratic. So, start off with no variable, -9. Has a degree of 0, we call that a constant. So, degree of 0, constant. X minus 4. Could have been x minus anything or even y or any other variable. But that has a degree of 1, we call those linear. Again, these are things you've seen before. You've worked with linear, you've worked with quadratic, maybe just not exactly in this format. X squared plus 3x minus 1, that's a degree of 2, that's called a quadratic. Obviously I'm going in order, so then my next one is going to be with 3. Again, this would be something very good for that note card that you might get to use on the next test, which I will let y'all know tomorrow when that would be, because I need to look at my calendar, how I've got everything planned. X cubed plus 2x squared plus x plus 1. Are they all pluses? That's obviously degree 3. That's a cubic. So the next one will have a degree of 4. That's called a quartic. Quartic. I think 4 quarts make a gallon. And finally, we got up this as high as we go is 5. Degree of 5, that's called a quintic. Quintic. I think it's quintic, but it could be quintic. Tomato, tomato, we'll go with that. All right. Longer than it is to work the problem. And it takes longer to say, write the directions here than it is to work out the problem. Okay, so what we're going to do is we're going to take an example, we're going to write it in standard form, which means just put it in order. Then from there, you're going to identify the leading coefficient, the degree of the polynomial, the number of terms of the polynomial, and then based on the degree and terms, you will name the polynomial. You'll give me a specific name of what it is. If you can somehow remember all that yourself, I guess you'll be okay. If you know what the heck you're talking about when you're doing the example, it's up to you.
Is that how you read a question on the test?
Oh, I'd probably put it in bold and then say give you a couple of problems like that. But yes, I could.
Are you going to start doing that more multiple choice like you said you would?
I'd like to. I'm going to try to as best as possible. My 2x squared plus 4x cubed minus 1. That is not in order. Okay, that's not in standard form. So let's put it in standard form. Put it in order. 4x to the third. Plus 2x minus 1. Oh, look at y'all being awesome. There we go. Okay, now that's in order. What's the leading coefficient? 4. What's the degree? 3. How many terms? 3. Okay. Terms are monomials. How many different monomials? The 4x cubed is 1. 2x is the second one. The 1 is a third. I'm not worrying about the plus and minus because that just helps separate them. Okay? So here I have a leading coefficient of 4. That will be more important later on as we're looking at characteristics of the graph. Degree of 3, the term 3. So we can now name this polynomial. Give it a name based on its characteristics.
Well, what's the term? What is quadratic?
Term is like how many different monomials you have. Like 4x cubed is 1. Then when I get a plus, I get a new monomial. That's 2x is another one. Minus gives me another one of 1. So I have 4x cubed, 2x, and 1 as 3 different terms combined into one polynomial by the plus and minus.
Oh, so like with the example that we took earlier, where it was like had some
Degree and the terms. Notice degree first, term second. So degree is cubic. How many terms? This is 3 terms. We can give it a more specific name. With 3 terms, what would that be? Trinomials. So this is a cubic trinomial because it has 3. So this is a cubic trinomial. And that's it. Like I said, it's a lot easier to answer this question than it was to write down those directions. Okay, binomial. 3 is a trinomial. 4 or more we'll just say is polynomial. Just poly. Sure. The book will tell you like you should say polynomial with like 4 terms. Just say polynomial. I don't. Whatever. Okay. Here I've got 7x cubed minus 11x plus x to the 5th minus 2. What should be first? X to the 5th. Then after the x to the 5th would be 7x cubed plus 7x cubed, then minus the 11x, and then minus the 2. So once you've got them in order, then you can look at all the other things. Go ahead. So get them in order first, then decide what's the leading coefficient, what's the degree, how many terms does it have. So what's the leading coefficient? 1. What's the degree? 5. How many terms? 4. Okay. And then from there you can get the name. Degree of 5 is what again? Quintic. Quintic, and since it's got 4, quintic polynomial. 4 or more, we'll just say polynomial.
Why is the leading 1?
Because there's a 1 in front. The leading coefficient is that number in the very front. Once you've got them in order, the number in front. Do you see a number in front of the x to the 5th? The leading coefficient has nothing to do with the exponent. It's the number that's in front. X to the 5th is 1. 7x cubed is the second term. 11x is the third term. 2 is the fourth term. Every plus and minus gets you a new term.
Sir, how do you know which one's the leading coefficient?
It's when you put them in order, it's the number that's in the very front.
But how do you know how do you find the biggest exponent?
You put them in order from biggest exponent to lowest exponent. So it goes x to the 5th, x cubed, x number. And so that now that I've got it in order, then I can say that the leading coefficient is 1. Yes, ma'am?
Will there ever be a degree greater than 5? Right?
No, not for this test. Not for y'all.
It's always going to be polynomial.
Yes, after 4 or more, it'll always be polynomial. Okay, so let's keep in mind, these are different, let's say, term names. A monomial is when it has 1 term. Binomial is when it has 2 terms. Trinomial is when it has 3 terms. And polynomial is when it has 4 terms. Well, I'm sorry, 4 or more. Okay. And again, something you can put on the note card for the next test. Should be. But there's a lot of things that I thought were common sense last semester that some people still found ways to miss. Adding and subtracting, folks, is just combining like terms. Again, now remember, when you say something like 7x squared plus 3x squared, you just add the coefficient. 7 plus 3 is 10, but you do not add the exponents. You do not add and make that, say 7x squared plus 3x squared is 10x to the 4th. It's just 10x squared. Okay. Now, the way I like to do this, I'm going to show you how I like to create columns and try to make sure everything's in order, everything's lined up. You don't necessarily have to do it this way, but for those of you that are, let's say, a little weaker, that might be the better way to do. Keep yourself organized. I know it's kind of a strange concept, but sometimes organization does help. So I've got these columns. I'm going to create these columns. And I'm going to put the terms where they belong. But I like to put them in order. What's the highest exponent you see in either polynomial? 3. Okay, so what I usually like to do is then I'll say there's a 3, a 2, a 1, and a number. Like an x cubed, x squared, x's, and numbers by themselves. So like if you look at the first one, 3x squared would go in that second column. The 1x plus 1x would go in this third column, and then plus 7 in the last column. Put them in order. And then the next polynomial, I'll have the 14x cubed plus 1x squared minus 1x. Notice I'm also putting the coefficients for the ones that are missing coefficients, plus 2. And now I can combine. Straightforward, right there. So I have 14x cubed plus 4x squared. 1 minus 1 is 0x plus 9. And no, since I have a 0x, you don't have to write that. You can write your final answer as just 14x cubed plus 4x squared plus 9.
Do you have to put that little graph?
No, you don't have to put that little graph. I'm just suggesting it as a way of making sure you don't make simple little mistakes. Because if I do make this multiple choice, I will have, say, some like little easy mess-ups for y'all. Like 1 minus 1 suddenly became 2 because y'all are not paying attention.
Wait, so how did you do those? You took the biggest one from both sides?
Yeah, from either the biggest exponent from either one. Okay, and then that's where I started my columns and started creating columns like, okay, I know my highest degree is 3, so I had a degree for column for 3, 2, 1, no degree, or 0 degree. I should say 0 degree, but I put their number. And then I started placing the terms where they belong in those columns. Notice the first row is the first polynomial, the second row is the second polynomial.
Is the first one always by itself?
No, just happen to be.
Yeah, let's say like on the left side there was like a 3x to the third power. Would you?
Then that would have been on top of the 14, and that would have said 3 plus 14. Mm-hmm.
So you're just combining.
Yes, you're just combining like terms. Any other questions? No, you don't add the exponents. Again, keep in mind, you only combine, you're using the exponents to decide which ones are alike that you can add the coefficients. You do not add the exponents.
Are we going to do multiplying and dividing?
That would be tomorrow, multiplying. Dividing is actually section 3.
What, you already did that though.
Huh?
Just kind of review.
Yes, this is like I said, this chapter is when we start seeing lots of new stuff that you haven't seen before. Starting with, say, the second half of section 2 tomorrow, that's when that's going to happen. Whoopsie. What was that? Here. This one's going to be subtraction. Again, this is where y'all make lots of simple mistakes. And sometimes y'all think, oh, I got it wrong, so that must mean I don't get it and I don't understand it. And I'll just keep flunking because I'm never going to get it. It's a bunch of BS. In all honesty, folks, I mean, because, again, you look at something like this, it's not really much different than, say, my second grader going, well, little Johnny has 4 apples and 3 oranges, and little Susie has 3 apples and 7 oranges. How many oranges and apples do they have all together? Except we've replaced the oranges and apples in the little pictures with x's and x to the 5th, x to the 4th, x cubes, and stuff like that. I mean, if you honestly look at it, and you look at the teacher's plan, like the teachers say lesson plans, that's technically when you look at the TEKS for first grade, or even kindergarten, it says there's algebraic thinking for little kids. That's what it is. When they're using the idea of saying 4 apples, that's like saying 4x for y'all. We just replaced the apples with x's. I'm sorry, y'all don't get the cute little pictures. All right. What's the highest degree here? 2. So you've got the 3x squared, or the negative x squared. So I'll go 2, 1 number. So I got negative 1x squared plus 1. Notice how I kept the signs with the various things that they were. The minus stayed with the x squared. The 1 was a positive, stays plus 1. What's going to happen to the signs of everything in the second polynomial because of the minus?
What's going to turn opposite?
It's going to turn opposite, change. So,
why is it? Oh, okay.
So minus 3x squared, minus 2x, and then plus 5. The minus distributes to the second polynomial and changes the sign of all of them. So now I can combine like terms. Negative 1 minus 3 is negative 4. There's nothing to go with the negative 2x, so I just bring that down. 1 plus 5 is 6, and you're done. With that example.
How do you do that again? How did you line them up?
How do I line them up? I find the highest exponent I see in any part of the problem. Okay, and the highest exponent I see here is 2. So I wrote like a little 2 to say that's the x squared, like that's the degree of 2. Then after, what's after 2? Let's start counting down. 2, 1, and then I should really say this is a 0. I should say this right here is a 0. Okay, so 2, 1, 0. Well, let's see here. The x squared, that's a 2. There was no just x. Then just a number by itself, the 0. Okay, and then the next one I have, because of the minus, I changed the sign. Minus 3x squared. So I've got all my x squareds lined up. I do see an x, so I bring that one into that x column, the 1 column, and then the 5 number by itself. Then I can combine straight down. Like I said, I think that's a very helpful way of organizing it. You don't necessarily have to do it that way, but it can be very helpful. Especially with subtraction, when y'all forget to make sure you change the sign of everything in that second parentheses. When she gets back. Oh, I was ready to get up right now. All right. Any questions on that? No, that was changed to a 0. Yeah, I just kind of see that too. Oops. All right. So here we come to our last set of examples, graphing higher degree polynomials with a calculator. So we're not going to make you graph these by hand. We might later or get an idea. But, you know, for the most part, the idea here is that you can find, I mean, you might have to graph these, but you'd be doing it through your calculator and then drawing some type of rough graph on your paper. On a quiz, I might give you the graph and tell you need to identify like how many real zeros and where is it increasing and decreasing, something like that. I'm still debating how we're going to look at this. But here's x cubed minus x. If you were to draw it on the calculator, this is the graph or something close to it that you would see. Every time we've done this, where you've done a graph trace on the calculator and found the zeros. The zeros are where they cross the x-axis. Okay, how many times do you see this graph cross the x-axis? 3 times. 1, 2, 3. What's the degree?
3.
How many times across the x-axis again? What's the degree? Okay, kind of see a point there? Okay, those crosses, where it crosses the x-axis, those intersection points, those are called real zeros. Real zeros. Okay, they're real because we can find those. The ones we can't find are the imaginary zeros. But let's face it, if you can find the real zeros, then you can also identify how many imaginary, and we'll come to that in a second. But notice, here we have 3 real zeros, and we have an exponent of 3. So that would tell you that no matter what, there should be as many zeros as there is the exponent, the degree of the polynomial. Exactly.
So what is that x going to be?
The x is what kind of causes that little curve. That will kind of help cause that little curve. Now, I can divide this into different sections, and that's what I'm doing here. And those different sections, I can see there's a different pattern. Like in this first section to the left, the graph is increasing. It's going up because I'm reading from left to right. In the middle section, it turned and started going down, decreasing. Then it turned again to create a third section and be increasing, going up. Okay, so you can see here, everywhere it turns, and these are max and min points, which we can find with the Inspire real easily, it will change how the direction of the graph. First, in this one, it was increasing, then decreasing, then increasing again. Okay, so here's the next example. Again, you could graph this on the calculator, but here's the graph. That's supposed to be 3x cubed plus 2x plus 1, and there's the graph. How many real zeros? Okay, again, we're only crossing the x-axis. 1. Okay, don't worry about the y-intercept. There's only one real zero here. If there's only one real zero, and I could have 3 zeros possible, how many are imaginary? 2. You can easily find that out. So if you know there's only one, because the graph's only crossing the x-axis one time, and that would tell you that there's probably 2 imaginary, 2 answers that would deal with I, which we will get to. later in the chapter, not today. Okay, and this is increasing. If you notice here, it's always increasing. It's always going up. There's no turning. I mean, there's curves, but there's no turning point where it like goes, like starts going up and then it starts going back down. Okay, this example, I believe, goes x to the fourth something. Okay, yeah. X to the fourth minus 8x squared plus 1.
There are 4 zeros.
And there are 4 zeros, 4 possible zeros. Now, I look at the graph. How many of those 4 zeros are real?
3.
No, all 4.
1,
Yeah. 1,
2,
2, 3, 4. Okay, there are 4 zeros there. Now, if there had only been 2, then I would have said there's 2 imaginary. You know, right now we can see that there's 4. Okay. And then, like in this first section, is this increasing or decreasing? Okay, decreasing, right? Because it's going down. Remember, we're reading from left to right. So we're starting from the far left and we're working our way across. Okay, in the second section, increasing. Third section, and last section, increasing. Very easy. That would be super easy to do on a test. There you go. And again, we said there's 4 real zeros. Okay. That covers section 6.1. You'll have the assignment tomorrow, but there you go.